Hello and welcome to this section of the Algebra Tutor. In this section we're going to learn how to simplify expressions in order to solve equations. So it's kind of a two-part process. First we've talked about expressions. What are expressions in algebra? And now we're going to learn how to simplify those guys, how to simplify expressions. And the reason that we're doing that ultimately is because we're going to want to solve more complicated equations. So you already know the basic idea of how to solve an equation. You want to isolate that variable. You want to get the variable x or y or w or whatever it is. You want to get it by itself. And we've solved quite a few equations where you've kind of add things to both sides or subtract things or whatever to get the variable by itself. But now, when we get to these equations in this section toward the end of it, the expressions will be a little bit more complicated. We'll have to do a few more steps. So in order to be able to solve more complicated equations, you need to get your skills really, really good in the area of how to simplify expressions. And this is very similar to, in principle anyway, to what you do with fractions. We all learn what a fraction is. We learn that 2/4 is a fraction, for instance. 2 out of 4 pieces of pizza, right? And we learn that we can simplify that fraction. And it's the same thing as 1/2. 2/4 of a pizza is the same as 1/2 of a pizza. We learn how to simplify those fractions. And we learn that 2/4 is exactly the same thing as 1/2. There's really no difference in how much pizza it is. Those things just look different when you write them down. One is more simplified than the other. The 1/2 represents the simplified fraction, right? We spent a lot of time with fractions learning how to do that. It's the same thing here. You'll have an expression. It'll have x's and exponents and things running around. And when you simplify it, you're basically kind of bringing it to a simpler form. You're kind of expanding it, or you're simplifying it in a way that lets you isolate that variable, which is what you want to do anytime you're trying to solve an equation. So before we solve any equations, let's start with baby steps and learn how to simplify expressions. So what if we had something that looked like this? What if you had 3x plus 17x? And I said, hey, we want to simplify this. How do we simplify this expression? I mean, obviously, you have 3 times some unknown thing called x. We don't know what x actually represents. It could be, any number in the world. Plus 17 times x. And again, x is some unknown number. But whatever number x actually is, it's the same thing here as it is here, because anytime you see x in an equation, everywhere you see it, you don't know what x is, but everywhere you see it, it's the same number. So you know how we solve equations, we find that x is equal to 1 or x is equal to 2 or something. Everywhere in the expression that you see the variable, it's going to represent the same value, after you solve the equation. Of course, there's no actual equation here. There's no equal sign. But the idea here is that whenever you multiply 3 times x, and here you take 17 times x, in both cases, even though I don't know what x is representing the same thing. So an analogy to this would be if I had 3 pencils over here, right? And then my other hand, I had 17 pencils over here, and I'm trying to add 3 pencils plus 17 pencils. How many pencils do I have? I have 20 pencils, right? Because 3 plus 17. And we know that because we have pencils here and we have pencils here, it's representing the same thing. So we can add them together, and it makes sense to add them together. So the same thing holds true here. You can kind of think of this as like 3, pencils. Even though this is going to represent the number, it's a value of something. This is 17 times the same thing, basically. So you can sort of think of this as 3 pencils and 17 pencils to help you realize that it makes sense to say that when you add these things together, it's 20 pencils. The x here and here and here signifies that you're really talking about the same thing. So the bottom line is when you simplify expressions and you add things together, you can only add the numbers together if the variable is the same. If it's the same. And that's why when we add it together, we get a 20, and we have to carry through that it's 20 x's. So it's 3 pencils plus 17 pencils is 20 pencils. In algebra, you'd say 3 x's plus 17 x's is 20 x's. And it makes sense to add them together because we have the same variable everywhere. All right? Now let me ask you another question. What would happen if you had, 3 oranges plus 17 used cars? Well, could you add them together? Could you add those together? Well, sure, you could add the numbers, 3 plus 17, but what would it represent? What would that even make sense? If you have oranges and used cars, yeah, I guess you could say you could add them and it represents the total number of objects you have, but since oranges is so different from used cars, it doesn't really make sense to add them together. So if you had 17y here, a different variable, then you would not be able to add these together because they're representing different things. So in algebra, I'm trying to give you these examples to help you understand why, but in algebra, the bottom line is the only way you can add things together that have variables in them is if you have exactly the same variable like we have here, and then when you add them, you have to carry the variable through because you're talking about x's, and you get 20 x's. So let's expand that to another example. What if you have 8x squared minus 5x squared is equal to 3x squared, right? That's what that would be. You take the 8 and you subtract the 5 and you're going to get 3. And the reason you're able to do this is only because you have x squares here and x squares here. So if I kind of did that a little too fast. If I cover this up and I say, here's an expression, simplify it. Well, you need to look and say, well, can I actually do the subtraction? The only time you can do the subtraction is if whatever the variable is here matches the variable here, and the exponent has to match. Basically, you have to be talking about exactly the same thing. X squares are here, x squares are here. If I took away the square here and just made this 5x, you would not be able to subtract this because they would be different. But because they're exactly the same, x is the same here, the exponent is the same here, then you can actually do the subtraction. 8 minus 5 gives you 3. 3 what? 3x squares. All right, so you're dealing with x squares here, and you have x squares here. So let's go and do a different one to kind of illustrate the point a little bit. We'll switch colors for now. What if you have 9x plus 3y, and I say, go ahead and simplify this expression. You know, a lot of students, first thing they'll do is they'll say 9 plus 3. I'm going to go and write that number down, and that's going to be somehow in the answer. But you're going to be smarter than that because you're going to look and say, well, here I'm dealing with x's, here I'm dealing with y's. These guys are different. I cannot add these things together. I can't add them. So if somebody asks you to simplify this expression, the only thing you can do is write down, this is already simplified. In other words, you can't do any more than this. This is like when you get down to a fraction, like 1/2. You can't simplify it anymore. It's already as simple as it can get. So it looks a little bit weird that this is simplified because it doesn't look so simple, but it is. And the reason it is because you're dealing with x's here and you're dealing with y's here, so you can't add them. This is what I was telling you. It's like trying to add bulldozers to chipmunks. I mean, you could add the numbers, but bulldozers plus chipmunks, they don't make any sense. They're not representing the same thing, so it makes no sense to add them together. So when you add things in algebra, you have to have the same variable along with whatever exponents. They have to be the same as well. Okay, so let's go and do another guy here. What if you want to simplify the expression 3 parentheses x plus 2 plus 4x, and you're asked to simplify this expression? Well, this is a great example in algebra of when you're going to be expected to use things that you already know in order to actually do it, because you have this giant parentheses here. And a lot of students, they'll start trying to add things and everything, but notice that what's inside the parentheses, you can't actually do anything with it, you know, because here you have 1x, and here you have the number 2. There is no x after the 2. So here you're dealing with x's, and here you're dealing with just a number. So you actually can't add this inside of here. This is already simplified inside of the parentheses, so there's nothing you can do there. But what you do notice is that you have a 3 out front, and we have learned the distributive property, so we can actually distribute that 3 in to both things inside. So here you'd have 3x plus 3 times 2 is 6, and don't forget you're still adding a 4x over here. Now what do we have? We have 3x plus 6 plus 4x. Notice we have 3 x's here and we have 4 x's here. So we have the same variable here as here, same exponents on the x. So we can add 3 plus 4 and that'll give us 7 x's. And then we still have the plus 6 left over from earlier. This is the final answer, 7x plus 6. And this is fully simplified because here we're dealing with x's and here we're dealing with a number with no variable. So this is like apples and oranges. You can't add them anymore. This is as simplified as you get. You have how many x's you have plus, you know, just how many numbers you have. So that's fully simplified. Let's do another guy like this. Let's say we have 5 parentheses z minus 3 plus 2 times z. How would you simplify this expression? Well, same thing. You look inside the parentheses and you realize you can't do anything with it. You can't subtract these because you have a z here and a 3, and you don't have a z near the 3, so you can't really add them or subtract them or anything inside of there. But we can distribute this 5 in, like that. So what we're going to do is do 5 times z, giving us 5z. 5 times negative 3, negative 15. The negative basically comes from the negative inside of here. Don't forget you're adding 2z over here. And then we'll switch colors to black real quick just to kind of help us out. And what we have here is 5z minus 15 plus 2z. So this is a common term with this guy. I have z's here and I have z's here. So 5 plus 2 is 7z. And you're still subtracting 15. Don't forget you still have that negative there. So it's 7z minus 15, and that is fully simplified. You have z's here, you have no z's here. So because I don't have any commonality, I can't add them together. I can do that here because I have z's that I'm talking about. So the bottom line in algebra is you can only add things or subtract things from one another if they're basically the same thing, if they're describing the same thing. Either they're going to be numbers, in which case, of course, you can add or subtract them. But if they involve exponents or any kind of variables, the variables have to match along with the exponents. They have to match. And if they don't match, you can't add them together. All right? Now, just so you know, when you have something that matches like this, it's called like terms or common terms. So if your teacher says, hey, circle the common terms here, or circle the like terms, you would circle the 5z and you would circle the 2z because those are like terms. If you were doing it here, you'd circle the 3x and you'd circle the 4x. Those are like terms. And because they're like terms, you're able to add them like this. All right, now what if you have x plus 2 in parentheses minus x minus y? And we're asked to simplify this expression. First thing you do, of course, is you go inside the parentheses and see, can I add these together? Well, you can't add these together because there's no x over here. So you can't do anything there. This is dealing with x's and this is dealing with y's, so these are totally different. You can't add them. But the only thing you do realize is that anytime you see a negative sign outside of a parentheses, you really need to realize that it's like a negative 1 out here. So there's like an implied 1 right there. So basically, you can distribute that negative 1, because it's just a number, inside of the terms here. And there's also a positive 1 here, and so because it's positive 1, you can distribute it in, and you're just multiplying by 1. It's not going to really do anything. So let's go ahead and go down this road. So what you're going to have is you can strip the parentheses off here. They're not really doing anything necessarily because there's no number out here other than 1. So you'll just have x plus 2 for representing this. But when you get over here, you need to be careful to distribute this negative 1 in. So what's negative 1 times x? It's just going to be negative x. And what's negative 1 times negative y? It's just going to be positive y. Don't forget, negative times negative is positive. So you need to make sure and do that. When you distribute this negative sign in, you need to make sure and get these signs right. Now, can we simplify this? Well, I see right away that I have an x here and a minus x here. So when I take x and subtract x, it's going to give me 0. So they're going to basically disappear. And then what I'm left with is 2, and then over here, plus y. Usually you like to write the variable first, so it would be y plus 2. Same thing. 2 plus y is the same as y plus 2. And that is the final answer. You can't simplify this anymore because here I have y's that I'm talking about, and here I'm just having numbers. There's no y here, so I can't actually add those anymore. So that is the final answer. Now let's flex our muscles a little bit, and I think you've got the basic idea of how to do this. Let's start rolling in some of our other skills. 2 times 4x plus, here's a good old fraction, 9 halves, minus 3x plus 2 thirds. I told you, fractions would never leave your side when you're dealing in algebra, and it's better just to tackle it head on and understand it rather than hide from it. So here we have some stuff inside of a parentheses. Here we have some stuff inside of parentheses. We have fractions everywhere. So the first thing you want to do if you want to try to simplify it is go in here and try to simplify this. But you realize you can't because this is x's we're dealing with, and there's no x there. So we can't actually add this. Same problem here. We don't have any x's over here by the fraction, so we can't actually add them together. So we're kind of stuck there. But we notice that we have a number outside of this parenthesis, and we have a number outside of this parenthesis. So we're going to be able to distribute for instance, the 2 into here and into here, and we'll distribute the negative 3. Don't forget it's negative because of this. We'll distribute that into the second set. So how do we distribute a 2 in? Well, it's going to be 2 times 4x. What's 2 times 4x? Well, you multiply the numbers, and you're going to get 8 x's. All right? When you're multiplying things together like a number times 4x, you multiply the number and you carry the variable down. Because this is like 4 pencils, right? X could represent whatever, pencils. So 2 times 4 pencils, if you just put 8, it wouldn't make sense. You have to represent what you're talking about. So it's 8 pencils here. So 8x, for instance. And then we'll have, now let me take this one step at a time, 2 times 9/2. And we'll just deal with the actual multiplication later, but you should understand that we're multiplying 2 times 9/2. All right, and then over here we have negative 3x, because we're multiplying negative 3 times x. And then over here, we're multiplying negative 3 times this guy. So we'll carry the negative sign, negative 3 times 2/3. So that's what we have for this part here. Now the thing I want to point out to you here, and kind of why this problem was constructed this way, we have a 2 and we're multiplying by 9/2. So don't forget, anytime you're multiplying by a number, it's kind of like saying 2 over 1, basically. So it's kind of like you can imagine this fraction multiplying by this fraction. You have a 2 on the top and a 2 on the bottom. They're basically going to cancel, or they're going to divide out, basically. 2 divided by 2 is going to give you 1. It's going to disappear. Anytime you have something on the top and the bottom of a fraction, that's going to happen. And you have exactly the same thing going on over here. The 3 is going to cancel with the 3. I mean, when you think about it, 3 times 2 is 6. 6 divided by 3 is 2. So if you actually did the multiplication, you're still going to get 2. Same thing that you get by just canceling them out. That's what you're going to get there. So, continuing on, you'll have 8x plus, after this cancellation, you just have a 9 there, minus 3x, minus, after this cancellation, you just have a 2 there. All right, now we're finally to the point where we can add some terms together. We have 8x's here, and we have minus 3x's here, so 8 minus 3 is 5. 5 what? 5x's. You have to carry the variable along. And then we have some numbers. 9 minus 2 is positive 7. So it's 5x plus 7, and that is the final answer. All right, so the only thing that was even a little bit tricky about this is we had to distribute 2 times from the numbers on the leading part of it. And then when we did the distribution, we had to be careful about these fractions because we're taking 2 times 9/2, and that basically cancels. We canceled something here, so we had to deal with the fractions, and then we just simplified the terms, which is really what we're learning about here. X's go with X's, numbers go with numbers. So be careful in algebra. We're building skills, but you can't forget the previous skills. You know, you can't forget how to deal with fractions because you're going to get a big fraction on your test, you know, and then if you don't understand the basic fractions, you're not going to be able to do anything more. But I hope you can see that this is, you know, yeah, there's a few steps here, but it's not that hard. We're just applying what